Download this code from codegive.com, link in the description below. OK, let's dive into a comprehensive guide to manual transfer switches for 2024. This will cover everything from understanding the purpose and types of transfer switches to selecting the right one, installing it safely, complying with electrical codes, and even some troubleshooting tips. We'll also include a basic code example for a simplified monitoring system. Complete Manual Transfer Switch Guide 2024. Introduction, the importance of transfer switches. In the event of a power outage, a manual transfer switch allows you to safely connect a generator to your home's or business's electrical system, providing backup power for essential circuits. Without a transfer switch, directly plugging a generator into an outlet, backfeeding, is incredibly dangerous and illegal. Backfeeding can energize the utility lines, creating a severe electrocution hazard for utility workers and neighbors. It can also damage your generator and household appliances. Key benefits of using a manual transfer switch ***. Safety ** completely isolates your generator from the utility grid, preventing backfeeding. This is the most critical reason. Convenience * provides a structured and safe way to power pre-selected circuits in your home. No need to run extension cords everywhere. Code compliance * meets electrical code requirements for connecting generators to building wiring systems. Appliance protection * protects sensitive electronics from voltage fluctuations and surges that can occur during a power outage. Generator longevity * properly regulating power draw helps prevent overloading and damage to the generator. 2. Understanding the basics. What is a transfer switch? A transfer switch is an electrical device that allows you to switch between two different power sources, the utility grid and a backup power source, typically a generator. A manual transfer switch requires you to physically switch the power source. Unlike an automatic transfer switch, ATS, it doesn't automatically switch over when the power goes out. You have to do it manually. 3. Types of manual transfer switches. Manual transfer switches are available in various configurations. Here's a breakdown. Circuit breaker interlock kit ***. This is a more affordable option but requires some modifications to your existing electrical panel. It's a mechanical device that prevents the main breaker and the generator breaker from being on at the same time. It typically involves installing a sliding plate or interlocking mechanism. This is suitable if you have a standard breaker panel and only need to power a limited number of circuits. Pros * lower cost, relatively simple to install, for experienced DIYers. Cons * requires modifications to your panel, may limit the number of circuits you can power, requires careful operation to avoid tripping breakers. Pre-wired transfer switch, load center. This type comes in a separate enclosure with pre-wired circuits and breakers. You select which circuits in your house you want to power from the generator and connect them to the switch. This is a good option if you want to power multiple circuits and don't want to modify your main electrical panel. Pros * easy to install, less modification to the main panel, clearly labeled circuits, more flexible than an interlock kit. Cons * higher cost than an interlock kit, requires space for the separate enclosure. Meter mounted transfer switch * this type of switch is installed between the utility meter and the main service panel. It allows you to switch the entire electrical load of your home to the generator. This is the most expensive option and is usually only necessary for larger generators or homes with very high power demands. Pros * can power the entire home, depending on generator size, integrates neatly into the electrical system. Cons * highest cost, requires professional installation, often requires utility company involvement. 4. Selecting the right manual transfer switch. Choosing the correct transfer switch depends on several factors. 1. Generator size, wattage. The transfer switch must be rated for the maximum wattage of your generator. Exceeding the rating can damage the switch and create a fire hazard. Always check the generator's running wattage, also known as rated wattage, not just the starting wattage, peak wattage. 2. Number of circuits. Determine which circuits you want to power during an outage, lights, refrigerator, furnace, etc. Choose a transfer switch with enough circuits to handle your needs. Consider future needs as well. 3. Amperage. The transfer switch's amperage rating must match or exceed the amperage of the main breaker in your electrical panel, or the specific circuits you're connecting. 4. Voltage. Ensure the transfer switch is rated for the voltage of your electrical system, typically 120/240 V in North America. 5. Location. Consider the location where the transfer switch will be installed. Choose a model that is suitable for indoor or outdoor use, depending on its location. 6. Ease of use. Look for a switch that is easy to operate, especially in the dark or during stressful situations. Clear labeling and simple switching mechanisms are essential. 7. Certifications. Ensure the transfer switch is certified by a recognized testing laboratory, such as UL, Underwriters Laboratories, or ETL, Intertech. This indicates that it has been tested for safety and performance. V. Installation, Step-by-Step Guide, General. Important safety note: electrical work can be dangerous. If you are not comfortable working with electricity, hire a qualified electrician to install the transfer switch. Always disconnect power at the main breaker before starting any electrical work. General steps will vary depending on the type of switch. 1. Planning. Turn off the main breaker. Turn off the main breaker to isolate the utility grid. Plan the wiring route from the transfer switch to the generator inlet box. Mark the circuits you intend to power with the generator. Review the transfer switch manufacturer's instructions carefully. 2. Mounting. Mount the transfer switch enclosure securely to a wall or other suitable surface near your electrical panel. Ensure adequate clearance around the switch for access and ventilation. 3. Wiring, example using a pre-wired transfer switch. Neutral connection. Connect the neutral wire from the generator inlet box to the neutral bus bar in the transfer switch. Connect the neutral wire from the main panel to the neutral bus bar in the transfer switch. Ground connection. Connect the ground wire from the generator inlet box to the ground bus bar in the transfer switch. Connect the ground wire from the main panel to the ground bus bar in the transfer switch. Line connections. Connect the hot wires, typically black and red, from the generator inlet box to the appropriate terminals in the transfer switch. Connect the hot wires from the selected circuits in your main panel to the corresponding circuit breakers in the transfer switch. Ensure you match the phase of the generator and the circuits, L1 to L1, L2 to L2. 4. Generator inlet box. Install a generator inlet box, a weatherproof receptacle, on the exterior of your home. Wire the inlet box to the transfer switch. 5. Testing. Turn on the main breaker. Start the generator. Plug the generator into the inlet box. Switch the transfer switch to the generator position. Verify that the selected circuits are powered by the generator. Switch the transfer switch back to the utility position. Turn off the generator. 6. Electrical code considerations. Electrical codes vary by location, but some general requirements apply. NEC, National Electrical Code. The NEC provides guidelines for the safe installation of electrical systems in the United States. Article 702 covers optional standby systems, including generators and transfer switches. Grounding. Proper grounding is essential for safety. Ensure that the transfer switch and generator are properly grounded according to code requirements. Overcurrent protection. Each circuit connected to the transfer switch must have appropriate overcurrent protection, circuit breakers or fuses. Wiring methods. Use approved wiring methods, example conduit, NM cable, for all connections. Disconnecting means. A readily accessible disconnecting means, example a circuit breaker, must be provided to disconnect the generator from the electrical system. Signage. Label the transfer switch clearly to indicate its function and operating instructions. 7. Operating the manual transfer switch. 1. Power outage. When the power goes out, turn off the main breaker in your electrical panel. 2. Start the generator. Start the generator and let it warm up for a few minutes. 3. Plug in the generator. Connect the generator to the inlet box using a heavy-duty extension cord. 4. Switch to generator. Flip the transfer switch to the generator position. 5. Power restored. When utility power returns, switch the transfer switch back to the utility position before turning off the generator. This prevents a surge when the utility power comes back on. 6. Turn off the generator. Turn off the generator and let it cool down before storing it. 7. Turn on main breaker. Turn the main breaker back on. 8. Troubleshooting. Generator not powering circuits. Check the generator's fuel level. Check the generator's circuit breakers. Verify that the transfer switch is in the generator position. Check the wiring connections. Breaker tripping. Reduce the load on the generator by turning off some appliances. Check the circuit breaker rating. Generator not starting. Check the generator's battery, if equipped with electric start. Check the spark plug. 9. Maintenance. Regularly inspect the transfer switch. Look for signs of damage or corrosion. Test the transfer switch periodically. Operate the switch to ensure it is functioning correctly. Maintain the generator. Follow the manufacturer's maintenance schedule for the generator. Xcode example, simple generator monitoring, Python. This is a simplified example using Python and a Raspberry Pi to monitor the generator's voltage and current. It assumes you have sensors connected to the Raspberry Pi that can read these values. This is an advanced project and requires knowledge of electronics and programming. Important notes about the code example. Sensor integration. You'll need to choose appropriate voltage and current sensors and connect them to your Raspberry Pi. The code will need to be modified to read data from these sensors. This will involve using the appropriate libraries for the sensors, example libraries for ADC conversion. Alerting. The send_alert function is a placeholder. You'll need to implement your desired alerting mechanism, email, SMS, push notifications, etc. Libraries like simplib, for email, and Twilio, for SMS, can be used. GPIO pins. If you're using GPIO pins, configure them correctly using the rpi.gpio library. Choose appropriate pull-up or pull-down resistors as needed. Calibration. Calibrate your sensors to ensure accurate readings. *Safety*. Be extremely careful when working with electricity and sensors. Isolate the generator circuit from the utility grid before connecting any sensors. Ensure that your sensors are rated for the voltage and current levels you are measuring. This project is best suited for experienced electronics hobbyists. 11. Conclusion. A manual transfer switch is a crucial safety device for anyone who uses a generator to provide backup power. By understanding the different types of switches, selecting the right one for your needs, installing it properly, and following electrical code requirements, you can safely and reliably power your home or business during a power outage. Remember to consult with a qualified electrician if you have any doubts or concerns about the installation process. The simplified monitoring code is a starting point to improve the safety of using the generator.